Good morning, everyone. Really amazing to be here. Rad, I really loved your talk. We are actually working right now with a customer on prophecy cameras, and I can tell you that it is possible to do processing on MPU class devices, Cortex-A only, no acceleration. So we're getting there, but it's tough. All the interfaces, the memory, you're spot on with the challenges that we have in the space. So lots to come with event-based cameras. I think the trick with everything is how do we get the technology in the hands of the engineers who build real things? And that's my theme of this year, putting ML in real products. If we don't do that, it's gonna be a bunch of us research nerds, right, who have super ninja teams building really, really specialized algorithms that nobody can really achieve in everyday companies who have real products to make. So democratization is the key. We need more data on this, however. So that's something we did. We did a survey with over 1,000 developers, and we asked them, what's working? What do you have struggles with? What tools are you using? Really fascinating. I'm gonna dive into that. We found 3 major things that are shortcoming right now. Where do we get data for real applications? It's not big data. It's very custom data from real industries with real problems. How do we get that data and turn it into useful data sets? How do we achieve reliability that engineers understand, not data scientists, right? Accuracy on your training set is not anywhere near sufficient for an engineer to say that, yes, this can go in my turbine, right? They want to understand, what does this mean from an engineering point of view? How do we get to that level of reliability? And finally, how do we deploy these algorithms on this whole scale of hardware in our embedded world, right? Cortex-M0 all the way up to, yes, NPUs and GPUs, the high end of the spectrum. People building real products have to make use of all that hardware. But first, I always like to start with a real application. This is a case that we worked on recently together with Advantech, one of the world's leading industrial product makers. They make industrial gateways, cameras, systems of all types. On NVIDIA hardware, we went and solved the manufacturing problem that they have, which is, are workers getting into safety situations which slows down the manufacturing line? Are there stops on the manufacturing line that they're having to look for manually from the floor management point of view? We found by creating a computer vision model from the top down, we could do some very simple things to detect when these safety and stoppage violations happen and gain a 15% overall increase in production line efficiency, just like that. So really amazing, simple use of computer vision, doing this on embedded hardware and getting a direct factory floor improvement for the people there.